Guys, so welcome back. This is Sir Shafat Khan on your screen. Okay, so today we are going to continue doing the same paper 2017 of winter paper 2 variant 2. All right, we've done the first two questions in the previous previous lecture, right? And today we're going to do the remaining paper in this video. Okay, so now question 3 says the elements in group 2 they show trends in their properties that are typical of metals. Elements in group 17 show non-metallic properties. State and explain the trend of ionization energy down group 2. So this is a typical question of ionization energy. So what happens to ionization energy as we go down any group, not just group 2, any group. Going down the group, you guys know the radius is increasing, charge density will decrease. And if the radius is increasing and charge density is decreasing, then obviously the energy needed to remove the outer shell electron will also decrease, right? Because the outer shell electrons become less tightly attracted to the nucleus, and as a result of which the ionization energy will fall or decrease. We've done this in class as well, right? So if you have this atom right over here, okay, and this is the outer shell electron, for example. If this distance from the nucleus, this is the nucleus, which is positively charged, and the electron is negative. If this distance or the radius it increases, then obviously the ionization energy needed to remove this outer shell electron will decrease. All right. So that's the important stuff over here. And by the way, we also have a recorded course on AS chemistry in 32 lectures. All right, a crash course. So if anyone is interested in buying those, you can just drop me a text on my Instagram, which is SFK Shafat Khan. All right, this is my Instagram handle. You guys can drop me a text there, and it's a paid crash course over there. And in just 32 lectures, you can revise your entire AS chemistry. All right, it's a very amazing crash course, and is highly recommended for those who are preparing right now for their CAIs. All right, and they require quick revision. Anyway, so we need to state and explain the trend. So I'm gonna write this down over here. Since going down the group, atomic radius decreases, and atomic radius is one of the most important points that you need to mention in your answers. Okay, atomic radius decreases down the group, decreases. If atomic radius decreases, then that means, sorry, it doesn't decrease, it increases. Right, it increases. Atomic radius increases, due to which the charge density decreases. And if the charge density decreases, then the outer shell electrons, therefore the outer shell electrons become less tightly attracted to the nucleus. So lesser energy would be needed to remove them, and ionization energy will decrease. Okay. Let's move on. So then explain the trend in melting points down group 17. So what happens to the melting points as we go down the group 17? Just recall group 17. Group 17 which starts out from fluorine, then chlorine, and then bromine. You have iodine and acetylene. Now, as you go down the group, these two are gases, right? The gases. This is a liquid. Bromine is a liquid. Iodine is a solid. So what's happening to the states? States are becoming stronger and stronger. This means melting point is actually increasing, right? Because solid have a higher melting point compared to the gas. So state, and you need to explain it as well. So what is the melting point dependent on in group 17? In group 17, the melting point actually, since they're all nonpolar gases, not just gases, meaning they're all nonpolar elements, therefore the melting point depends on the strength of van der Waals forces. So going down the group, the strength of van der Waals forces, it increases, right? So down the group, it's just a 2-mark answer. So down the group, strength of VDW forces increases, or van der Waals forces increases. Therefore, melting point increases. Okay, so 1 mark for increase and 1 mark for increase in VDW forces. Take it. Let's move on. Part 2. The melting point decreases down group to explain the strength. Why? What's the reason behind this? Why does the melting point in group 2 decreases down the group? Down the group, you first of all, you need to identify what the melting point of group 2 would be dependent on. Since they are metals, so metallic bond would be responsible for the melting point, right? Metallic bonds. So down the group, again, atomic radius is increasing, right? If the radius is increasing, then that means the bond length is increasing. And if the bond length is increasing, then that means the atoms are less tightly attracted to each other, correct? And so lesser energy would be needed to remove them, all right? So again, it's because of the increase in atomic radius, okay? So atomic radius increases down the group. Due to which charge density decreases, because you guys know the charge density and atomic radius are inversely related. Charge density decreases. So metallic bond strength would decrease, right? So the electrostatic forces of attraction between the atoms, which are the metallic bonds, would become weaker. Electrostatic forces of attraction i.e. the metallic bonds would become weaker. So lesser energy would be needed to remove them, therefore the metallic therefore this melting point decreases, okay? Electrostatic forces of attraction, metallic bonds, and you guys know what the metallic bonds are, right? They're in between the positive metal ions and the sea of delocalized electrons. They become weaker. Then some reactions based on group 2 metal barium are shown over here. So this is barium, all right? It can go to form barium nitrate and hydrogen, or it can go to form barium hydroxide and hydrogen, or it can be heated to give you a solid X. Now state the reagent needed for reaction 1 and 2. All right, so if you look at reaction 1, it's giving you nitrate and a hydrogen gas, right? When do we get a hydrogen from a metal? When metal is reacted with an acid. Which acid? Just look at the anion over here. It's nitrate, so nitric acid. So the reagent used over here is nitric acid, HNO3. Okay. Reaction 2. What's happening in reaction 2? Barium is going to barium hydroxide and hydrogen. Now, this was also a reaction from inorganic chemistry. When you add in water, it will give you barium hydroxide and hydrogen. All right, because reactive metals, when they react with water, they also liberate hydrogen again. So this is water. Name X and write down the equation for its formation. All right, so if when it is heated in air, air means it's a supply of oxygen. So it will give you barium oxide. So name is barium oxide. Solid, right? Barium oxide is a solid, and the equation that you have, barium plus oxygen forming BaO. So let's balance it as well, because this equation always have to be balanced, and there you go. Moving on, part 3. Barium nitrate produced in reaction 1 is heated to dryness. The anhydrous solid is then heated strongly and decomposes. Barium oxide is produced together with the 2 other products. Identify the 2 other products of the decomposition reaction and state what would be observed. Now, see, it is heated to dryness. So this means it's decomposition of nitrates, right? So we have to identify the other 2 products and state what would be observed. So what was the decomposition reaction of all group 2 nitrates? When they're decomposed, they'll give you an oxide, nitrogen dioxide, along with oxygen, right? This is also theoretical knowledge that you need to know from inorganic chemistry group 2, right? So the equation is also balanced. Nitrogen dioxide is a brown gas, correct? Barium oxide is a white solid, and oxygen is a colorless gas. So identify other 2 products. What are the other 2 products apart from barium oxide? All right, so the other 2 products are nitrogen dioxide and oxygen. and observation would be a brownish coloration in the test tube, right? So test tube would turn brown because nitrogen dioxide is brown. Test tube would turn brown. That's the observation. Okay. Moving on. State what would be observed when the excess of magnesium sulfate is added to barium hydroxide, producing reaction 2, and explain your answer. All right, so what would be observed when an excess of magnesium sulfate is added to this, right? What would happen? You guys know magnesium sulfate provides sulfate, and sulfate when reacts with barium would give you barium sulfate. Barium sulfate is a white precipitate, whereas magnesium hydroxide is also a partially soluble solid, right? So the solution would turn cloudy, correct? So white precipitate would be formed of barium sulfate, which is actually insoluble, and magnesium hydroxide is also partially soluble. Okay, so what would be observed? When it is added, right? And explain your answer. So basically, let's write down the equation first. Barium sulfate reacts with barium hydroxide. It's always good to write down the equation to be on the safe side. All right, it will give you barium sulfate along with magnesium hydroxide. Now, take a barium sulfate is produced. Barium sulfate and magnesium hydroxide are actually produced, right? So let's write down the whole thing. Magnesium hydroxide are produced. Barium sulfate is a white precipitate. And magnesium hydroxide is also partially soluble, right? We've done this in theory. So a white precipitate suspended in a cloudy solution would be observed. This is just an additional line which I've written in the last. Okay, you can also stop here. Okay, magnesium sulfate is a white precipitate and magnesium hydroxide is partially soluble. Solution turns cloudy or white precipitate is observed and stuff like that. All right, so we've done question 2. If you have a question 3, actually, if you have any questions or confusions, you guys can ask in the comment section. Now, question 4. 4 says some reactions are shown based on methylpropan-2-ol. Right over here, this is methylpropan-2-ol. All right, and this is organic chemistry. Now the reaction 1 goes over here, reaction 2 comes back, and then reaction 3 goes straight, and then reaction 4 comes here. Now for each of the reactions, state the reagents and the particular conditions required, if any, for the type of reaction. So the type of reaction, choose from the following. Each type may be used once, more than once, or not at all. Each reaction may be described as one or more than one type. So these are the type of the different reactions that you have. You need to write down the reagents and the type of reactions for each of them. So if you look at reaction 1, this is methylpropan-1-ol, right? 2-ol, sorry. So let's write it down. This is the formula of methylpropan-2-ol. We need to convert it into a bromine, right? Brominated product. So what is this? This is actually nucleophilic substitution reaction with HBr actually, right? Because you are actually removing this. You are removing the hydro OH and replacing it with another nucleophile, that is bromine, right? So it's a nucleophilic substitution reaction, or you can just write down substitution for alcohols, okay, but not for alkyl halides. This is a substitution reaction. And the reagents, there are a number of reagents that can be used. Concentrated sulfuric acid, H2SO4, along with sodium bromide can be used, all right? These are in combination. Because you guys have done this reaction as well in previous inorganic chemistry, and you guys know that this also releases out HBr, or you could just use HBr directly. Okay. Reaction 2 now is coming back to alcohol. So for the reverse reaction, it's also a nucleophilic substitution reaction, but this time you have to add in another reagent, right? You can add in water, because you guys have done this as well. Water, what will it do is it will replace the bromine, add in water molecule, and then the water will lose a hydrogen. Okay, or you can add in OH negative ions, which are also nucleophilic, right? But the OH have to be provided by an alkali, sodium hydroxide or potassium hydroxide. And again, nucleophilic substitution reaction. Substitution reaction. And the reagent which is used can be water, or it can be sodium hydroxide or potassium hydroxide, can be used any, but they have to be dilute, okay? Aqueous dilute stuff. Okay, and since you're adding in water, so this can also be called hydrolysis. आगे चलते हैं. Part 3 says from the OH to an alkene. So this is dehydration reaction, right? You're removing an OH, forming an alkene. So dehydrating agent needs to be added. Dehydration is the type of reaction. And dehydrating agents, we've done two types, either concentrated sulfuric acid plus heat, or you can use the catalyst, aluminum oxide and silicon dioxide. ठीक है, आगे चलते हैं. Reaction 4 is conversion. Okay, so you've got this alkene, and this alkene is converting into two different products. And these two products, why are we getting two products? Well, this must be, since it's an alkene, the most common reactions that alkene undergo is electrophilic addition reactions, right? And since if you look at the products, you have a bromine in there and a hydrogen on the other side. So this must be addition of HBr over here. Now, and since we have two different products, because these must be two different isomers of each other, okay? So it's an addition reaction. HBr has to be added in over here though. So you can get two different products over here, which must be isomers of each other. So this is gonna be an electrophilic addition reaction. Let's write down the whole thing, electrophilic addition reaction, okay? It's addition of HBr and no special conditions required. Okay. Then part B says draw a diagram to show SN1 mechanism for reaction 2 and include all necessary charges, arrows, curly dipoles, stuff like that. So reaction 2 is right over here, and its nucleophilic substitution is going from this to this. So let's write it down over here. Okay, so CH3 thrice C, then Br. Let's first write down it in an expanded form. Let's expand this formula. So if you expand this formula, it will look like this. It's carbon having 3 methyl groups. And a bromine atom. Okay, now this is a tertiary alkyl halide, correct? It's tertiary, so it cannot undergo SN2. It has to undergo SN1 mechanism. So for SN1 mechanism, what the tertiary alkyl halide does is, first you are going to add in the partial charges. This is partial negative and this is partial positive. Okay, now once you've added in partial charges, then you're going to heat it. Okay, and heating, what heating does is it actually breaks it down and it breaks down the weakest bond. Okay, the weakest bond is the polar bond in this case, and these electrons which are in here, the carbon bromine bond is the weakest bond, and these electrons, both the electrons would be transferred to the more electronegative bromine atom, because bromine is already trying to attract these electrons towards itself. Once these electrons are transferred to bromine atom, you're gonna get a positively charged carbocation complex. A complete positive charge would be achieved on carbon, and the bromine would get a complete negative charge, okay? Because it has accepted the electron from carbon, and carbon has lost its electron over here. And now, once this has happened, now the nucleophile that we are going to use is OH, and it's going to come in. OH is the nucleophile that we have over here. Okay, it's a nucleophile because it has a negative charge and it has a lone pair of electrons. So Nucleophiles have a lone pair of electrons and they are attracted. Nucleophiles means nucleo means nucleus, right? So they are attracted to the nucleus, and nucleus has a positive charge. So they are actually attracted to centers of positive charge. So what the OH will do is it will use its lone pair and attack this positively charged carbon atom. Now, guys, be very, very careful while drawing the curly arrows, because examiners are very, very strict while checking the curly arrows. If the curly arrows are even slightly deviated up or down, you lose marks here, okay? So be very careful. And now once this attack is completed, then you're going to get your final product, in which you have the tertiary alcohol along with Br negative as the byproduct. All right, CH3, and then this is your OH and Br negative. Okay, so now marks distribution. So first mark, second mark, and third mark with all the partial charges and dipoles. Of course, if you lose out the partial charges and curly arrows, you lose out marks. Okay. If you have any confusions or questions over here, you can ask on the chat box or in the comment section. Once this is done, let's move on to the next part. It says 1-bromobutane is a structural isomer of the product of reaction 1. Define the term structural isomer and name the different types of structural isomerisms. So what is structural isomer? I'm going to write down this definition once over here. Isomer is any substance that is same. Iso means same, right? And mer is referring to the molecular formula, but structural isomers are those which have the same molecular formula but different structural formulas. Okay, so what is a structural isomers? Structural isomers are compounds having the same molecular formula but different structural formulas. Compounds having the same molecular formula, but different structural formula. And what are the different types of structural isomerisms that we've done in our course? So we have the chain isomers, right? We've got functional group isomers. If you guys don't know the details of this, you can buy the paid course, and then it has all the detailing available. Functional group isomers, chain isomers, and positional isomers. Okay, these are the three types of structural isomers. In chain isomers, it's the carbon skeleton that's different. In functional group isomers, it's the entire functional group that is different. And in positional isomers, the functional group is the same, but the position of the functional group is different. All right. And in all three cases, the molecular formulas are the same. 1-bromobutane is treated with the same reagents as in reaction 2. Butane 1-ol is formed. Identify the mechanism of this reaction and explain why this reaction proceeds by a different mechanism from reaction 2. This is 1-bromobutane, right? Which means it's a primary alkyl halide. Just look at its formula. Butane means 1, 2, 3, and 4 carbons, and 1-bromo means on the first carbon. So it's primary alkyl halide, right? The carbon to which the alkyl group is, to which the halogen is attached, is directly attached to 1 carbon only. All right, it is treated with the same reagent. So if it's a primary alkyl halide, remember from theory, we know that primary alkyl halides undergo SN2 mechanisms, right? Because as they cannot undergo SN1 because the carbocation which is formed is unstable for them, right? So they have to undergo it using an alternative mechanism. And so the mechanism is SN2, all right? And explanation is because the carbocation formed is primary, right? First, we need to identify that alkyl halide is primary. So 1-bromobutane is a primary alkyl halide. 1-bromobutane is a primary alkyl halide. Carbocation it will form would also be primary. Due to which it will have a low positive inductive effect. Positive inductive effect is the key term, and you have to actually write down this point whenever you are explaining the carbocation stabilities concept, okay? Because this is the key term which almost always has marks, okay? Because and it will have a low positive inductive effect. Okay, will also be primary, due to which it will have a low positive inductive effect and would be unstable. And would be unstable. And it's assumed that if it's unstable, it won't form more. Okay, it will be unstable. So SN2 mechanism, 1-bromobutane is primary, and so the carbocation intermediate is unstable. All right, because of the lesser positive inductive effect or limited positive inductive effect. Now, the product of reaction 3, methylpropene, does not show stereoisomerism. Give 2 reasons why methylpropene does not show stereoisomerism. Okay, so what are the 2 types of stereoisomers? Let's quickly revise them. You've got optical and you've got cis trans, and in case of an alkene, you can only have cis trans. You can have both actually if a branch is present, but cis trans is present only in alkenes. Okay, cis trans cannot be present in compounds that are not alkenes. Okay, so they must be talking about the cis trans isomerism. So let's just look at it. Methylpropene, prop 1, 2, and 3. Okay, so methylpropene, this is propene, and this is the methyl group over here, and this is the name methylpropene. Okay, so if you look at the methylpropene, look at the carbon atoms over here. Cis trans isomerism. To show cis trans isomerism, the basic condition was you need to look at the carbon-carbon double bond. Now, each of these 2 carbon atoms, now just look at this one. This carbon atom must be directly bonded to 2 different atoms. Now, in this case, it is bonded to 2 hydrogens, so cannot show cis trans, right? So therefore, it cannot. And same applies on the second carbon as well. The 2 bonded groups are also exactly identical, so again cannot show cis trans. So that's the reason. Give 2 reasons why methylpropene does not show stereoisomerism. So the first reason is because the groups which are attached to the carbon atoms, they are identical. All right, and if they're identical, so this was the first reason. What is this? The second reason is for optical isomerism. All right, and for optical isomerism, there is no chiral center in there, right? For optical isomerisms, you have to have a chiral center. There is no chiral centers. Okay, for 2 reasons. No chiral centers are present. What are chiral centers? You can find out in the course. Okay, no chiral centers are present. And the double bonded carbon atoms are directly attached to identical groups. That's the second reason. So no cis trans isomerism either. So no optical, no cis trans. 2 says methylpropene can be polymerized to form a polyalkene. Say the type of polymerization and draw the repeat unit of polymer formed from methylpropene. The type of polymerization is always addition polymerization for alkenes. All right, and the repeat unit for polyalkene for methylpropene. So what is the formula for methylpropene? This is how methylpropene looks like, right? Hydrogen, hydrogen, methyl, and methyl. So if you have this formula, all you need to do is just open up the ends and remove this bracket and add another bracket and add an N. That's the repeat unit, okay? So carbon, carbon with the methyl and methyl groups up here and up down here, with 2 hydrogens up here and down here, with both the ends open and a small N over here. So this is a single repeat unit of this polymer. Say the difficulty association with disposing of polyalkane. So you know what they are non-biodegradable, right? So if they are non-biodegradable, they cannot be broken down. That's the only difficulty that you have. Non-biodegradable plastics, degradable plastics. They're non-biodegradable. They cannot be broken down by bacteria. And name the 2 products of reaction 4, name of this and name of that. So you just need to name them. All right. So how do you name them? So just first write down this, just expand the structure. So CH3, CH3, and CH3. The very first thing that you need to do is identify the longest continuous carbon chain, which right over here is This one, right? You've got 3 carbons in the same line. If you have 3 carbons in the same line, so 1, 2, and 3, 3 carbons in there. On the second carbon, you have 2 branches, right? You have a bromo branch and you have a methyl branch. Now you have to arrange them alphabetically, all right? B comes before M, so the name is going to become 2-bromo dash 2-methyl. All right, you need to put dashes to separate the alphabets and numbers, and then the name of the straight chain, which is propane. Propane. Okay, it's an alkane in the middle. And then the last one, again, you need to open up the chains. So carbon, carbon, this is bromine, and then this carbon has 2 methyl groups, right? Again, identify the longest continuous carbon chain. In this case, you've got 1, 2, and 3 carbons, okay? And similarly, yeah, so 3 carbons right over here. Wait a minute, 1, 2, 3, 4, yeah, so 3 carbons in the straight chain, and there is a methyl group on the second carbon. So 2 methyl, 1 bromo, right? So 1 bromo, 2 methyl propane. It's that simple. Okay, longest chain is right over here, first, second, and third. And you start out from the first carbon, which is nearer to the bromine atom. Okay, and there you go. We are done with the paper finally in 2 videos. All right, so I'm going to upload this video right now, and once done with that, I'm going to solve the next paper with you guys. Till then, stay tuned, and Allah Hafiz. If you have any questions, you can reach out to me on Instagram handle SFK Shafahat Khan. I'm repeating this again and again for all A-level students. And this video is also helpful for all those who are preparing for AKU or NMD CAT exams as well, because it has a lot of A-level concepts being tested in those tests as well. And these concepts have been tested over there as well. All right, the ones which I've been doing.